Hello, welcome to this lesson of the Linear Algebra Tutor. In the last couple of sections, we started talking about determinants of matrices, and I showed you the row reduction method to find the determinant of a matrix. That's always going to work. Whatever size matrix you have, you can always do row reduction techniques, keeping track of what you have to put out in front of the matrix, negative or a scalar constant or something, and then multiply by the diagonal elements. You can always do that. But you have to admit it's a little bit cumbersome, because even for a 3 by 3 matrix, depending on what the matrix is, you have you have to recopy the matrix several times to get down and to get it into triangular form. It can take half a page of work or a page of work, depending on what that matrix is. Also, most of the matrices that I teach you have whole numbers. What if your matrix has a bunch of fractions in it? Then multiplying and adding fractions in a bunch of row reduction steps is very, very cumbersome. So what I'm going to show you here is the way that I like to take determinants of 3 by 3 matrices. Outside of teaching you this, what you have to learn in this class, when you're in a class, you have to learn lots of different things. But when I'm sitting down with a pencil and paper and I have to take a determinant of a 3 by 3 matrix, this is how I do it. It's something I learned a long time ago. It's stuck with me, and it has saved me many, many times, even faster than typing something into a calculator. Also, I'm going to give you a little preview. In the next section, I'm going to teach you how to take the cross product of two vectors using this method. And that's just saves you a lot of time too, because if you have studied cross product of vectors, you know that the formula they give you in the books is really cumbersome and kind of long. I can teach you how to take the cross products of two vectors like this. It's exactly the same method that we're learning here. So kind of pay attention, make sure to keep it locked in your brain. I promise you this is something you'll use for many years to come. All right, so if we want to find the determinant of a 3 by 3 matrix, this will always work. And it's not really a trick, it's really a subset of a much broader technique that I will introduce you to in a few sections from now, but I want to show you it for a 3 by 3 because it's very easy to understand. And plus 3 by 3 is the most common system you're going to come up or encounter. So this is your matrix. Let's say 1, 2, 2, 3, 1, 4, 1, 2, 1. Very common for you to have a matrix like this in an actual problem. So let me switch here. It's going to be a little bit weird, but let me show you. And once we get through it, I think you'll kind of get the hang of it. The determinant of A is going to be equal to the following. Notice how your first row is 1, 2, and 2. Basically, we're going to end up expanding this determinant about that first row. So the first row, the one that you have at the top, is kind of important. So you don't need to rearrange rows or anything. It's just whatever is at the top, that's what you go with. So the determinant is going to be the first guy here in the first column, the number 1. And if you take the number 1 here, and notice that it's a part of this column and it's a part of this row. Mentally, you don't actually scratch it out on your paper, but mentally cover this up and cover this up. So if I cover these guys up, the intersection of the rows and columns here, what's left over? I have a small, what we call a sub-matrix, a small 2 by 2 matrix in this case, 1, 4, 2, and 1, all right? So I have the 1 here from this guy, and I cover up the row and the column that intersects to make that, and I say that it's equal to this times the determinant of the sub-matrix that's left over, 1, 4, 2, 1, and I write it just like this, all right? So it's the first guy times the determinant of the small submatrix that's left over. Now the good thing about it is you know how to take determinants of 2 by 2 matrices. That's why this is so easy. Because you know the crisscross method, multiply this way, subtract for a 2 by 2 matrix, finding this determinant, you don't have to do any row reduction or anything. You can just write that down because you know what the determinant of a 2 by 2 matrix is. But we're not done. We've just done the first part. We've used the very first element in this top row. Now we have the second. So it's going to be 2, this guy, times the determinant of the submatrix left over when I cross this out and I cross this top row out. You have to cross the intersections there. So cross that row out, cross that row out. You have 3, 4, 1, 1. Make sure you understand that's the submatrix left over. 3, 4, 1, 1. Now I'm not going to put a minus or a plus here yet. I'll explain why in just a second. But you have basically the very first element here times the determinant of the submatrix left over. You have this guy here multiplied by the determinant of the submatrix left over. And then now finally we have a 2 times, what do you think we're going to do? Times the determinant of whatever the submatrix is that's left over. So we cover this up and we cover this up. We have 3, 1, 1, 2. 3, 1, 1, 2. All right, so that's basically it. Now, in order to actually do it, you have to figure out what to put it here. The only thing in this method that you have to remember, and you really have to remember it or you're going to get it wrong, is for the middle element, you have a determinant here, a determinant here, and a determinant here. You have to put a minus sign there, okay? And then you have to put a plus sign for the next element. So it's basically plus, minus, plus this next guy here. And I'll actually explain, remember I'm kind of giving you a little tease. This technique I'm showing you is always bulletproof, it always works, but it is it's a subset of a much broader general procedure. And instead of teaching you the broad general procedure, which is kind of cumbersome to show you all at once, I'm teaching you what you will use constantly throughout your education. So this is what I use all the time. I'm always expanding it about that first row there. This negative sign, it basically comes about when I teach you the full glory of the procedure. But for now, all you need to remember is that you always need to put a negative sign for the second term. All right, so let's finish this problem up. This is going to equal, now everything's very easy. We have a 1 here. Whoops. We have a 1 here. And then I open a bracket or a parentheses to make it easier. 1 times 1 gives me 1. 4 times 2 gives me 8. So I have 1 minus 8. I can do this in my head if I want, but I want to make it explicit. Make sure I don't make any mistakes. Minus the 2 from here. Open up another bracket. I'm doing a crisscross. 3 times 1 is 3. Minus 4 times 1 is 4. Make this a bracket like this. And then I have a plus. The 2 comes from here. And then I'm crisscrossing. 3 times 2 is 6. Minus 1, crisscrossing this way. And then it's very simple just to get the answer. I'm going to just kind of simplify here. I have a 1. This is going to give me negative 7, so I'll have a negative 7. Then I'll have minus 2. This will give me a negative 1. And then here I have plus 2, and this gives me a 5. And so I'll just kind of cruise down here and say negative 7. This is plus 2. And this is plus 10. So if I look at that, I have negative 7 plus 2 plus 10. This guy is going to give me negative 5. When I add it to this guy, it's going to give me a positive 5. So the determinant of this matrix is this. Now, look at the work I've done on the board and think about what you would have to do if you did it by row reduction techniques. Row reduction, I would have I have a 1 up here, fortunately, which is good. I'd have to do one step to make these a 0, and then another step to make this a 0. And then I would have diagonal elements. I'd multiply. I'd have to make sure I kept track of anything out in front. And so for this particular matrix, not too bad, but this is bulletproof because I'm just taking 1 times the determinant of the submatrix, 2 times the determinant of the submatrix that's left, 2 times the determinant of the submatrix that's left. And then finding these determinants are basically very, very simple. So I want you to remember this. We're going to do a couple more examples here. And keep in mind, though, that this is useful for finding determinants of 3 by 3 matrices, and it's also useful for determining the cross product of 2 vectors in 3 dimensions, which is something that most books don't teach you at all. I'm just going to teach it to you because I think it's one of the most useful things you can know as a student. All right, so let's go and do the next problem. What if we're going to find the determinant of this B matrix, and we're going to say it's negative 2, negative 3, 1, 0, 0, 1, 1, 1, 1. We want to find the determinant of this matrix. All right, so we'll say the determinant of B is equal to. It's very simple and it's very bulletproof. You just go across the first row, negative 2 times the determinant. So I'll put this in parentheses. Negative 2 times the determinant of the submatrix. We cover up this column, we cover up this row, 0, 1, 1, 1, 0, 1, 1, 1. Then you have to remember the minus. The minus goes just because of the procedure. Then we have a negative 3 here, so you have to keep track. That's a negative 3 that comes from this times the determinant of what's left over here. Cover up that guy, cover up that guy. You have 0, 1, 1, 1. 0, 1, 1, 1. Then you have a plus. The final guy is a 1 times the determinant of the final submatrix. Cover this up, cover this up. You have 0, 0, 1, 1. 0, 0, 1, 1. Like this. So you have this guy times the determinant of the submatrix, this guy times the determinant of the submatrix. Don't forget your negative sign. This guy times the determinant of the submatrix. Now, these submatrices are very, very simple to deal with. Okay? So what you have is negative 2 you have, this is a 0 minus 1. 0 minus 1 when you do the multiplication. This becomes a plus, so we can make that a plus 3. When we do this guy, we're going to have 0 minus 1 again. And then here, it's going to be plus 1, so we can leave that alone. And then finally, this will be 0 minus 0. So we can just put a big fat 0 here. So the determinant of b is equal to, this is negative 2 times negative 1, which will give us a 2, positive 2. This is 3 times the negative 1, so that will give me a negative 3. And this is a 0. So the determinant of b is negative 1. Is negative 1. Not very many steps, right? I mean, you could do the row reduction. It's fine. There's nothing wrong with that. But you have to think a lot. Do I multiply this row by a number, and then I add it? And also keep in mind that these matrices I'm doing to illustrate the technique, they're simple. I have lots of ones. What if I have fractions in there? 2/4, 6/7? Yes, you might have determinants with those fractions, but I think it's easier than rewriting the matrix over and over and over and over again and doing all these row reduction steps with a bunch of decimals or something or fractions floating around. All right. And our final guy that we're going to do to illustrate how to find the determinant of a 3 by 3, just to give a little more practice, 5, 2, 3, 5, negative 1, 2, 1, 2, 3. So once you get good at expanding this, it's very, very simple. So the determinant of C is equal to, go across the first row, 5 times the determinant, and I'll put this in parentheses to keep it straight, times the determinant of the submatrix left over when we cross this guy and cross this guy. So we have negative 1, 2, 2, and 3. Negative 1, 2, 2, and 3. You have to remember the negative sign for your second term. Then we have a 2 times the determinant of the submatrix that's left when we cross this guy with this guy. 5, 2, 1, 3. 5, 2, 1, 3. And then we add to it, we have the third guy times the determinant of what's left when we cross this guy out with this guy. We have 5, negative 1, 1, 2. 5, negative 1, 1, 2. All right, so we've expanded it. Basically, we call this expanding the determinant about the first row. Okay, so this determinant will be 5. And then here we do a crisscross. So we have negative 3 here minus, this gives us 4. 2 times 2 is 4. And then we have the negative 2 here. This becomes 15 minus this direction becomes 2. So you just got to remember that crisscross, right? And then we have the 3 inside here. 5 times 2 is 10 minus negative 1. And I leave it like this so I can remind myself. If you just start doing too many sign manipulations in your head, you probably make a mistake. So I'm going to leave it like that. In the next step, then I'll say this is going to be 5 times negative 7. Okay. Over here, this is going to be negative 2. On the inside, 15 minus 2 is going to give me 13. And then over here, I'll have a 3, and then 10 minus a minus 1 is 10 plus 1, which is 11, like this. All right. And so what I'm going to have then, 5 times 7 is 35, so this is negative 35. 2 times 13 is 26, so it's negative 26. And then 3 times 11 is 33. So if you do this, and plus this, you're going to end up with the determinant of the matrix C is negative 28. Negative 28. And again, I could have done row reduction. I could have put a 0 here, a 0 here, a 0 here. It would have taken me 2 or 3, maybe 4 steps. I would have had to keep track of any modifiers out in front, depending on what steps that I have to do. And in general, when you do it the row reduction way, there's no right way to get to the answer. There's many different ways in which you can do it. So it always works. It's just that it's not going to be consistent between different students. People will do it slightly differently, hopefully arriving at the same answer. When you expand it about the first row like this, there's only one way to do it. It's this times this determinant, this times this determinant, this times this determinant. Do not forget, you have to have a negative sign that you insert in that middle guy. So that is how I do my determinants of 3 by 3 matrices. If I'm solving a systems of equations in electrical engineering and I've got a matrix here and I need to find the determinant for some reason, to use Kramer's rule, for instance, that I've covered in my matrix algebra tutor, you need to find the determinant of the matrices. This is how I'm going to find the determinant. I'm never going to bust out row reduction just because I know it always works, but I just prefer this. The other huge advantage to this is I'm going to show you in the next section how to take the cross product of 2 vectors using this method. And I think once you see that, you will understand why you should commit this to memory. So I encourage you to work these, make sure you understand it, follow me to the next section, and I'll show you how to make your life a little bit easier when you're dealing with vectors.